My name is Jerry Blackthorne. I'm the one waving my hands right now. Thank you, Samuel, for that great introduction. Now I got to live up to everything he just said. Thanks a lot. Yeah, I'm proud to call Samuel my friend too. Been working together for several years. He runs a very organized program, and I just try to live up to it. So let's check out the chat here. We got 54 people here. Oh my gosh. You know, it's Saturday, right? You can go outside and do things. So no, this is the place to be. We're going to have fun today. So we have 2 hours ready for you. And the 2 hours are going to be hands-on. You get to do stuff. So the first thing I want to do is I want to get you on Discord. So nothing wrong with Zoom chat. Zoom chat serves its purpose, but Discord is a little bit better. You know, it's got syntax highlighting and stuff like that. But we do have we have some assistance this morning with Sherry. She's around here. Cherry. She is in Discord, and she's going to be in the Zoom chat too. So it's going to be interactive. You get to ask questions. You get to do whatever you want. You get to participate. So one of the first things that we shared with you already is the Discord chat. So out of the 56 people, we got 26 right now or so in Discord. You could be in either one. You know, Discord is just easier for me to copy and paste like pictures and stuff. I don't think you can paste pictures in Zoom, but correct me if I'm wrong. Okay, so let's get my face off the screen here, and let's get to sharing the screen, since that's like where the fun stuff is, right? Okay. I always like to open my classes to making sure we're in the right class together, which is always a good idea, right? So here's the class that we're going over today. And how about in Discord? Someone want to confirm that you can see my screen? Does that look good? See my little face right here? Does that look good? Yep. Okay. Thank you very much. All right. So this is the workshop you're in. You're reversing with Ghidra. It's going to be a 2-hour workshop today. So you don't have to have a reverse engineering background to do this. So that's important to know. It is good to know about basic knowledge of programming. So if you don't have much of a programming background, you'll still pick up things, but it's okay sometimes just like sit back and just like watch instead of that, you know, frantic pace, try to click everything I'm clicking and like, it's okay. Just soak it in, let it wash over you, you know, get what you can get. So this is what we're going to do. We're going to kind of go over the major features of Ghidra. If you've never used Ghidra before, or you've never done any reverse engineering before, this is going to be a good intro to that. And the nice thing about today, the environment, we have exercises for Mac, Windows, and Linux. So in the Discord channel, we have pinned a message, and the pinned message has the link to all the binaries. And I'll tell you what, I'm going to grab this link again and drop it directly in the channel, because somebody somewhere is saying to themselves, pinned messages, what's a pinned message? So here we go. Try that right there. And this is what you should see. It's public, so you shouldn't need a login or anything. And let's see. You should be looking at something like this. It says binaries a folder and binaries.zip. That look good? I mean, can you have access to that stuff? Here? Yeah. Okay. Now, this is just a zip file of the folder. You don't need both of them. But if you go into binaries here, let me show you. Got a whole bunch of great stuff for you. These are all the same exercises. It's only RE1 through RE6. Now, you have, here's Mac, RE1 through RE6, Windows, RE1 through RE6, and then Linux. Got a little treat here for you. Linux, because that's what we specialize in our training institute. We have 5 separate architectures. So x86, x64, ARM, MIPS, and PowerPC. Are there any embedded systems people out there? Yep. All right. Well, embedded systems people, you're in the right place. You know, so we got you. Yeah. So I saw a response there on Discord. It says that so they all have .exe. So .exe is just a name. It's just the name of the file. And that helps people just identify that that's an executable. So it has nothing to do with whether, like, what type of file it is. And so I'll demonstrate that right now. Let me go here. This is my virtual machine here. It's like our standard training virtual machine. Updated for winter, of course. It's supposed to be winter right now, but it's like 70 degrees in Boston, which is a bit odd. So let's go here. Desktop, Jupyter, workshop. No, sorry. Here we go. Workshop. Okay, so for those of you who may be confused about the .exe extension, let me show you. I'm going to run the file command on all the files, and you'll see here, see the ones in the Mac directory? They're Mac OS, Windows is PE32, and all the ones here for Linux. See, ARM, MIPS, PowerPC, x64, Intel, but they're all ELF files. You dig? They're all ELF files. So don't worry about the .exe. That's just there for your convenience. Okay. It says Windows is empty. Windows files are hidden. Permission issues? Oh, really? Okay. Well, let's fix that then, huh? How about this? Did anyone, so, okay, you can't see the Windows here. So let's get the Windows to you. Let's do it. Now, here's a way I think that we could probably quickly resolve this. Just download the binaries.zip. It's not very big. So go to the, just download binaries.zip. That should have all the files in it. And then somebody's going to give me a confirmation. Binaries.zip did not have the Windows in it. Very interesting. Okay. Well, let's fix that, huh? Okay, so here we go. Yeah, so all the exercises are all the same. They're all the same exercises. But if you wanted to run the exercises, I just made them for each, thing. Okay. Let's see here. Now, if we take a look at all the binaries here, like in binaries.zip, and we go into binaries, we actually see in binaries.zip, there is all the Windows binaries, but I'm wondering, so they're in there. I'm wondering if Google Drive is throwing like a little tantrum about it. They're saying like it's, maybe it's malware or something like that. Don't know. Oh, you can't see the zip either? Wow. We're all over the place here. Okay, let me give you this here. Get link. Unable to share. Oh, look at that. I'm violating terms of service. Let's try this. Yeah, try that one. That's the Windows folder. Yeah, Windows. Yeah, I'm thinking it's probably because it's emptying out the file. Maybe it's like scanning it, thinking it's like, So, tell you what we can do. No, you will get malware. Yeah, double zip and password. Yeah, it's a good call. Well, I got one more trick up my sleeve here. And I got another download link that might work for you. And it's not Google. So here we go. Take me 2 seconds here, but I got you covered. Okay, I dropped it right into Discord. Can't beat that one, right? All right. So try it from Discord and then give me a yay or nay, and then we're gonna get this patty started. Everybody's trying to stop all the fun. Got him. All right. So Simon, you got the Windows binaries? Okay. So let's go here. Okay. Now, I think if you want to participate in this workshop, you should probably have Ghidra downloaded by now. So that's a good idea, right? You definitely want to have Ghidra downloaded. Now, I'm going to show you a little practical thing here with Ghidra, because some of you have some kick-ass 4K monitors, and you have to deal with this issue. You open it up, and Ghidra is like absolutely tiny. So I just want to demonstrate to you, this is what Ghidra looks like on a 4K monitor if you don't make the changes I'm about to suggest. So we're going to do this together. See, I wouldn't do this to you. I'm not going to make you learn through this. This is ridiculous, right? So it's too small. So here's what we're going to do. You got to go to your, no, you're not running 480p. Don't tell me that. Okay, here's how you do this. The first thing we're going to do is we're going to fix the size of Ghidra. So I'm assuming you have Ghidra installed and it's, you can run it or whatever, but here's what you're going to do. So in your Ghidra folder, and here's mine. I don't know where yours is, but here's mine. So wherever your Ghidra folder is, just go under the support directory. And then there's a file called launch.properties. Okay. So under launch.properties, there is this here, right here. Check it out. Okay. That's under launch.properties. So here we go. I'm going to make mine a 2, like this. And the here is the file. Here we go. Whoops. Here we go. What do I want to do? Yeah, it's under Ghidra and then support and then launch.properties. Okay. Now that's if you just want to make it bigger. Now that's what I'm going to do. So now, after you've done all that, that's kind of like the, that's like the boring logistic part. Now what we're going to do is we're going to jump into some of the fun part. So open up Ghidra. And I'm assuming you're opening it up for the first time, maybe. I don't know. And so you have like a blank project right here. It's just like this. Okay. Now, if you have a blank project, the next thing you want to do is we're going to make a new project. Okay. So file, new project, like this. Then just the default's fine, non-shared. And you can name this project, I don't know, RE workshop, whatever you want. It doesn't matter. Okay, RE workshop. Now, after you've made your project in Ghidra, we're going to import all of the exercises at the same time. So, this is Ghidra. We're going to import all the exercises at the same time. Once we get the exercises imported, I'll kind of like zoom out a little bit and we'll talk about reverse engineering, things like that. But we really want to get the programs just into Ghidra first. So here's how you do it. You go up to File and then go to Batch Import. So some of you may have been using Ghidra, but you haven't done batch import yet. So try batch import. And now just navigate to your directory with all the binaries in it. So for me, it's workshop here. and then I highlight all the folders like that. Okay. And there's quite a number of files too. Okay, 42 files all together. Check it out. So we got Linux, we got 5 architectures in Linux, we got Mac, we got Windows. So you can use whatever one you want. They'll all be the same pretty much in Ghidra. The one difference really is I had to switch up like one of the functions in Windows versus Linux. That's it. But what this allows you to do is that in each one of these, so I'll just go Linux x64 like this. So you can run each one of these on your computer. That's the idea. Like, you don't have to have it, but basically the idea is if you want to run the programs, then you can. Now, every one of these files that you now have in Ghidra that is that you can now run, each one of these is going to ask you for a password. That's the whole idea. So we have some motivation for actually learning reverse engineering is we're going to, you know, quote, crack software, basically. So with this, we're now going to launch the tool of Ghidra, the main tool. It's called the code browser. And you can use whatever one you want as far as exercises. The exercise I'm going to work on, if you want to like work along with exactly what I'm doing, the exercise is going to be Linux x64 RE1, like that. Okay. So double click the name of the binary and it'll open it up. Okay. Now you'll notice sometimes on my screen that see how it's like obscured like this. And that's because I have it on like 200% zoom, basically. Zoom is in like in magnification. I have 200% magnification in Linux so that you can see better. So sometimes it'll show up like this. Don't worry, it's not an error. You probably don't have that on your computer. That's just something I have. Okay, so it's going to ask you to analyze the binary. You just say yes. You're going to see all sorts of analyses here, but you don't really care about these just yet. So we're just going to hit analyze. Okay. All right. So now what we're looking at, I don't know. It's this overwhelming amount of icons and colors and windows and subpanels. I mean, it's crazy, right? This thing is absolutely crazy. So what is actually happening here? Well, let me kind of break down what Ghidra is actually doing. So here's a good time. Let me check in here with people, and I want to take a little poll here. So, okay. So I'm going to type a statement in Discord, and then basically you're going to give me a thumbs up, thumbs down, and let me know if you have any experience with reversing in Ghidra. So thumbs up, thumbs down that statement, and then basically that'll let me know. No, so thumbs up, thumbs down that statement. That way we can keep a track like of how many people can do which one. So the idea is that I just want to move as fast as you can move, basically. Oh, wow, that is very well balanced. 15 and 16. Okay. Okay. So I want to give you an idea here of basically what is Ghidra doing? Because if you just open up Ghidra and if you never reverse engineered before, which this workshop assumes you don't have reversing experience, but if you have, that's okay. We still got tons of stuff for you. If you have reversing experience, then you can just ignore the introduction here and just, start tackling those challenges. Now, for the rest of you who maybe not have reversing experience, I want to kind of give you a little intro here to reversing, like what is it? What's the point? How do we do it? You know, the basic stuff like that. So here's what I'm going to start off with. Life of a binary. Okay. And if you're wondering what this is a Jupyter Notebook environment. This is just what we use during all of our trainings. So I know you may have had to do some prep for this course as far as like, you know, downloading Ghidra and whatever. Like we take care of all that stuff. Like everything is bundled together, the commands, the Jupyter Notebooks, the exercises, things like that. So you get to focus on the fun stuff. So that's just what you're looking at right now is Jupyter Notebook. Okay. So for those of you who may just have programming experience with no reversing experience, I want to meet you where, you know, you may be, which is, this is probably your experience with computer programs, which is, you know, you write like a hello world like this, right? So, you know, hello, I don't know, hello workshop, something like that. And then you compile it and then you execute it, right? Hello workshop. There it is. And this is live, you know, it's not like, so this, as I'm typing it, it's compiling it. So this is where you actually spend your time making programs is, you know, in this type of editor and you're creating a program, you compile it and then you run it. And that's most people's experience with computer programming and computer science. Now, what we're going to do, I'm going to introduce you to is I'm going to introduce you to the sort of more detailed process here, that what's actually happening in the background. And the reason that that you may be interested in the more detailed process is because this is what's going to allow you to investigate programs in much more detail, to be able to do reverse engineering. So looking at this graphic right here, and I'll tell you what, I don't want this graphic to just float away. So let me grab this here and drop it in Discord. There we go. Okay. So you start off natural language. This could be like your work order. This could be your mission statement. It could be your homework assignment, right? And then after natural language, you put it into pseudocode. At least that's what you're supposed to do, right? You may not. You may just jump right on the keyboard and start typing. But after a while, you learn that's not a good strategy. So you have to plan out, design more. You go to pseudocode. Then after pseudocode, you start typing the source code. Now, that's what we just witnessed, the print hello workshop. We typed it in source code and the compiler took care of all this stuff and went all the way down to executable. Now, this in-between steps here, assembly, object, and then this step afterwards, process. This is all relevant if you want to investigate, you know, computer programs. So let me show you. And it's not a long process I'm about to show you. So here it is. We're going to start off with some natural language. It's going to be English in this case. You know, we check it out. Here it is. What type of file it is. I'm running the file command. It just says, okay, it's just text, no big deal. And then I cat it back out, just displays it on the screen. That's the file I just wrote. You know, real exciting stuff, I know. So we go from English to pseudocode. We check the file again. It's ASCII text. We cat it back out to the screen. There we go. Now we finally get to the source code part. And we're going to go source code, check the file type, cat it back out. It's all the same. Now, this is the first part where translation starts to happen, where we're going from one medium to another, and this is being done by a tool. So this is a really long GCC statement, and some of you might be interested in it. So let me copy it here. We didn't prep this workshop to have like Jupyter Notebooks too, because the overhead for like getting all of the Jupyter Notebooks out, it's really big. And it's just a lot of overhead for a 2-hour workshop. So for this, you're just going to have to, you know, look at what I got. And then if you come to do the workshop at Ring Zero, this is all the stuff that we actually go through. So this right here is going to translate the source code into assembly. Okay. There we go. So here's that program that we wrote before. It said hello again. You may be experienced in writing Python, Java, Kotlin, you know, Objective-C, whatever. All these things eventually get translated down to this assembly code, or sometimes people call it native code. This is the code that the processor understands. You can think of it that way. Like if you're running an Intel x64 processor, you have an x64 assembly code. If you're running an ARM processor, you have a separate ARM assembly code. So that's what this is here. We're looking at assembly code. Now, this is still human readable these are words: push, move, sub, push, call. That's human readable. Now what needs to happen is we need to translate that assembly actually into numbers, because your computer doesn't understand words. It only understands numbers, and ultimately just ones and zeros that are translated to voltages, positive and negative, right? So let's translate this here. And now when I cat it out, this file, you see it looks pretty funky here. I'm no longer seeing the things that I used to see before, like, hello world, or, the push. Like, it doesn't make sense to me anymore. It's because this right here is a series of numbers. To view these numbers correctly, you have to use a different tool called hex dump, like this. So this is a program. And you can do the same thing on the terminal. So I know you don't have the same setup I do, but if you go to the terminal and you have your exercise open, you can type hex dump and you get the same results. Now, I want to start off here for reverse engineers. So even people who have been around this, done this a long time, this is a good way that you can understand and explain it to other people. A program is just a series of numbers. There's nothing mysterious about programs. You don't even have to say it's a series of numbers. You could say it's a single number. And that's what hex dump is showing us. It's like, this is all there is. All of the information is right there. It's a puzzle. So a puzzle is like a type of game, right, where all the information is right in front of you and you need to solve it, as opposed to, like, say, more of an open-ended endeavor, like, say, go paint a picture of a cat. It's like, well, there's an infinite number of pictures of cats you could possibly paint. But a puzzle has like a solution and all the information is right there. That's what reverse engineering is, because programs are just limited in this way. It's just a series of numbers. Now, here is a very, very basic reverse engineering tool called OBJ dump, or object dump. This has now gone backwards. Instead of going forward, you've now taken the numbers that were created and you have translated it back to the instructions. What's actually happening here with object dump? It's taking these numbers that make up the program and it's cross-referencing it with a lookup table. Imagine you were given a short story in English and you had to translate it into Spanish. Well, you get your Spanish lookup table, Spanish dictionary, right? For every English word you see, you go over there, you look up the Spanish word, and then you sort of match them. And then that's the meaning, right? Now, practically speaking, English to Spanish wouldn't really work that well like that. But with computer programs, you can take the number 55 and you can look it up and it equals this. That is what a disassembler is actually doing. It's just cross-referencing. Now, for those of you old hands at reverse engineering, obviously, disassemblers are sophisticated lookup tables. They do a lot more than just, one-to-one like that. But that's what a disassembler does. So when we look at Ghidra back here, this main window, and you can just, in this main window here, you can just scroll down until you see code. And what do we see? We see here are the numbers and here are the instructions. Where do these instructions come from? Well, there is a published standard. There's like a lookup table right here. I'm in Intel x64. So you go to the Intel x64 lookup table, you cross-reference the numbers, you get that instruction out. That's what Ghidra is automating for you. Let me show you the reversing diagram. So that was really how things go forward. Partially how it goes forward. There's more to it. But what we're concerned about with Ghidra is not so much going forward here, but going backwards. So we don't really care so much about natural language to source code to executable, but rather we're given an executable and you got to go backwards. How do you get from executable back to assembly, back to source code, back to natural language? Now, when I say take an executable back to natural language, what I mean is somebody gives you a series of ones and zeros, and people are asking questions up here. They're saying, what does this program do? Well, If somebody wants to know what a program does, you know what a great description of that is? The program itself, just the ones and zeros. Like, here you go. This is exactly what it does. But people don't really understand that. So you have to take it to assembly. People don't really understand assembly. You take the source code. Finally, it ends up in like a report, like an executive summary, and you have to answer some questions. So you're translating this executable way all the way back to here. And sometimes the translation you're making is like the original design, sort of like, what does this program do? Does anyone know? Does anyone know some other questions you might want to ask about a program other than what does it do? Why does it do it that way? Yeah, that's a good one. So like, what were the design choices that went into the program? It's like the program downloads over HTTP. Why does it do it that versus FTP? Why doesn't it use SSL? Why doesn't it do this? So you start bringing in other questions like that. Why does it do it this way? Thought process. Yeah. Can it do something else? Ooh, Euler. Can it do something else? That's a great way to put exploitation. I know it was designed to do this, but can I also use it to just run any other program I want? Yeah, that's a really great way. Great way. Where is it vulnerable? Is the program exploitable? Who created it? Log4j, Log4j. So some other questions you might want to ask, and this is a popular one, which is, who made this? And here's kind of like a spicier question, which is, did we make this? And then people changed it and they threw it back at us? Is that what's happening? Because someone's going to get fired if that happened. That's a, little spicier question to be asking, but people will still have to ask it. So this is sort of like the nature of reverse engineering. Yeah. Repurposed 5 eyes. Yeah. So you start off in natural language, you have design documents, it gets translated down this way, forward engineering. And then eventually our job here, which is like the reverse engineers using Ghidra, we're going to go backwards like that. And what Ghidra specifically helps us do is it helps us take an executable, take it back to assembly. And then, as some of you may already know, is not only does it take it back to assembly, but it can then take it back to source code. So let me show you that. In RE1, so I want everyone here to sync up on RE1, whatever architecture or operating system you want. Doesn't matter. I want you to open up Ghidra and RE1. And then in this window right here, this is sort of your main window. It's called listing. So this is where I want you to go. And then you're going to type G for go. Okay. G for go. And then after you type G for go, I want you to type main to see if we can jump to main. If there is a main, sometimes there's not. Here we go. So we're in the main function of this program. Okay, so this looks like source code. I mean, it's pretty close to source code. It can't quite be compiled in anything just yet because it's like approximated source code. It's not really source code just yet. And here are a couple of things that stand out. So if we are to assume that this is like a C program, that's mostly the syntax being used here, a C program. C doesn't have a type called undefined 8. So that alone tells me like I can't actually compile this. But for any of you looking for a project out there, it'd be actually nice to have a Ghidra compiler. Just skip the step that we're about to do right now, all of the annotations and stuff, and just like make a compiler that understands what undefined 8 is. That'd be nice. Okay. So now that we are here, almost at the original source code, us as the people have to get in here and now start annotating. We have to start fixing up things. going back to the reversing diagram here, you see these first two steps, natural language. Well, how does it go from natural language to pseudocode? Well, a human has to do that. How does it go from pseudocode to source code? A human has to do that. There are some assistants, like support utilities that you can make like a UML diagram. It can generate source code. So there are some things like that. As far as I know, I don't know of any, I guess, popular utilities that you could like write a paragraph and then it would generate a program for you. But I'd love somebody to link me to that. That'd be fun. Now, after the two human steps, you have compiler, assembler, linker, and loader. We didn't touch on loader. But going backwards, Ghidra will take us from executable to assembly, and then it almost takes us to original source code. So right here, this is where we step in, the human, because Ghidra's decompiler is not perfect. Question there. Can you tell actually what's disassembler and decompiler? So your question here is, well, I guess maybe a naive interpretation of your question is I would say this is the decompiler over here, and then this is the disassembler over here. Did you mean, maybe you meant something a little different than that I wasn't picking up. So let's get off the academic high horse about abstraction layers and translations and things like that, and let's crack this program, and then we'll take it from there. So running this program asks me for a password, says no. Okay, thanks. Now over here, let's see if we can read this program. Now I see here it says you got it. Here I see it says no. So here's an if-else statement. And so what we're going to do is we're going to try to figure out what the password is here. So I see printf, enter password. I see scanf, and then this is where it gets really confusing. Especially if you've never used Ghidra before, this is pretty confusing. So here's what we're going to do. We need to figure out how we can start fixing this up and changing it subtly so that it starts to make more sense. So here's what we're going to do. Now, assuming you have some background in C, you know that the scanf function starts with a format string specifier, something like %d, %s, something like that. If you're not familiar with scanf or things like that, may I recommend to you the man pages. Type man scanf. Tell you everything you want to know. Okay. So here's what we're going to do. At scanf, go ahead and double click this. The decompiler here is synchronized with the listing display over here. So by double clicking it, it jumped to it over here. Now, what do we see? Well, I see a %s here in memory, %s. And what I see here is a label. That's what that is. Dat underscore, that's data underscore, and then data underscore, and then the memory address. So Ghidra could not figure out what this is, which is too bad. Ghidra, you should know better. I think you could have figured this one out. So Ghidra doesn't know what this is, so it just says it's data underscore the address. But us over here, with our knowledge of programming, are reading the man page for scanf and seeing %s here. What is this right here? This has a type to it. This information has a type to it. It's not just data. We can say something more specific. Who's going to type it first? Format string. All right, string it is. So let's do it. We're going to tell Ghidra, hey, Ghidra, you need a little help. Okay. Right click over here. Then go to data string. Give it a try. So let's make this a string right here. Data string like that. Okay. So now, Tyler, I'll get to your question in just a second. I saw you there. So if I don't answer your questions immediately, don't worry. I'll try to get back to them there. So we have changed this to a string. Now Ghidra understands this is a string. It now updates this to %s. Okay. We're making some progress. We have improved this. This is closer to being a program that I can actually understand. Now, given the context that this program asks us for a password, scanf %s tells us that it's taking in a string, and then it's putting in a variable called local28. Local28 is not a good variable name. If you're working with a partner and somebody starts naming their variables like this, you'd be like, you're not my partner anymore. You're fired. So why don't we give this an actual intelligent name? Okay. So somebody give a name here. What do you want to call this? Buff. We want something that's going to be relevant to input password, user input. Okay. I think input password is probably my favorite so far. So I like input password because it combines the different pieces of information. It's coming from input and it's the password. So here we go. Sorry, I did that fast. Right click, rename variable, L. L for rename. Okay, so we're going to name this, sorry, what was it? Input password. Okay, that looks a little bit better. And now you can kind of see printf, enter password, scanf, input password, string compare, input password, got to start somewhere, right? Okay, now that is all I would really need to do here to really just figure out what the password is. Now, this still would not compile. So for those of you who are interested in actually making this, like you can compile it, you're going to need to do more than this because you can't compile this yet. But what you can do is you can clearly see what's happening and then, what's being entered and what's being compared against. Yeah, as Simon says, or do strings. Big fan of strings. So now our input is getting compared to this. So go ahead, give it a try on the command line. Go ahead and copy. Let's do it. It never gets old. Got to start somewhere. I've been teaching reversing now for almost 10 years. And some of the people that I know that are, very talented, dedicate their lives to it. They do it full time. It's all they do. They don't do anything else but reverse engineer. There are some cases where when I first met them, they didn't know strings yet. They didn't know hex editor, things like that. But now, after beginning reversing, they find it fun. And now they're doing it professionally. And those people that I met, they weren't, hand selected for, the American or global all-star reverse engineers in mathematics or whatever, right? They're just like normal people. They just like to solve puzzles. So if you like to solve puzzles too, then you're in the right place. You don't need a bachelor's or graduate degree in computer science. You don't got to be some math genius. You don't got to be any of that. All you have to do is like to solve puzzles and not give up. If you can do those two things, then you're pretty much set. All the rest of the stuff you'll learn. you'll figure it out. But you definitely don't need like formal training on it. What I would say the most difficult part about reverse engineering, though, is the initial part. Getting over that hurdle of intimidation and learning the names of the tools and the process of going through it. But once you get through that, the learning curve, kind of levels off, and then you can kind of like start learning on your own. So that's what we focus on in our classes, or a lot of our classes, is like getting past the steepest part of the learning curve and then empowering you to learn on your own by challenging you with exercises and assistance and things like that. So anyways, if this is your first one, then, great job. Okay. So I got a question back there. Someone asked about the difference between, there's a couple comments. So one of them was, hey, did you know there's no bounds checking on this and you can crash the program? Hell yeah, you can crash the program if you're about that exploitation. Yeah, you can definitely exploit the program. But we're not really worried about that right now. We'll talk about exploitation, I guess, more towards the end. But we have a whole class on exploitation too. So let me go back here. So in addition to the workshops of reversing, what do we got here? Look at all these great, man, these people are very smart. Okay, here we go. So if you're already comfortable with reverse engineering and now you want to start applying your reverse engineering skills to exploitation, and you want to get past stack canaries, then we got a whole week on that for you. Like, it's an intense course. It's lots of fun. It's all guided, through like notebooks and stuff like this. So like, here's one. So here's one of our training notebooks, and we cover all that stuff if you're interested in exploitation. So return-oriented programming, defeating ASLR, pwn tools, non-executable stack canaries, all that sort of stuff, if you're interested in exploitation. Okay. Now, the other question that I saw pop up, which was, hey, what's the difference between a string and a terminated C string? So that the reference here was for %S. Came over here, go to data, and then I picked string versus terminated C string. Well, I can tell you what the difference from a programming point of view, right? Like what are these things meaning? Like, what do these mean? But here's something I want to highlight about Ghidra, if you do have questions about this, is the help system in Ghidra. Ghidra was developed at the United States National Security Agency over something like 15, 20 years. Millions of dollars of investment, people's time went into this. And you can see that in the help system. So here's what I want you to do. In RE1 for %S, go over there, right click this, go to data, and then I'm going to go to string, not click anything, just go over it, right? Now, after you've done all of that, go to and click F1. The Ghidra help system, it's not like just a placeholder. There are detailed tutorials, there are steps, there are screenshots, there are, everything you can think about as far as what these things are. It will tell you in great detail. This knowledge is not hidden anywhere. Like, there is more stuff here than you'll ever want to read or probably ever use. So if you wanted to know, hey, string versus terminated C string, right? So fixed length versus null terminated. So when you think of, if anyone's ever heard of read the manual pages as like a response, that's not my response here. But what I wanted to highlight here is the help system. Okay. Before we move on to RE2, any questions on RE1? Ooh, question. Oh, I saw one question come by there. Is there a recommended book to start with? Ooh, I guess I really wouldn't recommend. So there is a Ghidra book from Chris Eagle, although it's sort of like it's a gigantic compilation of knowledge. It's not really good for like sequencing and like learning. It's difficult to recommend a book to learn Ghidra. The Ghidra book is good for reference. So as far as learning Ghidra, I would say that start off with, I guess, what is the best one? I don't know. I'll have to get back to you on that. Yeah, I think so. Practical Malware or PMA is probably one of the greatest books that I have ever seen. So shout out to Mike Sikorsky for providing that to the community. Thanks, Mike. Terrific book, Practical Malware. That was the one that I think it's really meant for teaching, as opposed to the Ghidra book, which is kind of like more reference. So if my go-to, I'd say Practical Malware. It's a bit dated now, but it's still a great book. Okay, let's see. Another question here is, what would be my approach if function symbols are removed from the binary? So that's a good question. Actually, that's actually a great question. So here we go. Let's do this. Command line. I'm going to copy re1.exe to re1-stripped.exe like that. So the question was, how would you reverse engineer this if you didn't have any symbols? I mean, I kicked this thing off by doing G and then I jumped to main. Like, you don't always have main, right? So here's what I'm going to do. I made a copy of re1 and now I'm going to use the strip command. Now here's the difference. I just ran strip on the copy, and here's what I'm going to do. If I run nm on re1.exe, there's all of the symbols. And now I run the same utility on nm on re1 stripped. See the difference? re1 has all of these symbols, all of these labels for memory addresses. What does re1 stripped have? No symbols at all. So now that I have the stripped version, here's how I would approach this problem. I'd first run the program in a safe environment. There's no malware in any of these challenges I gave you, but you don't have to trust me. But there's no malware. Nothing's going to delete anything. Okay, so here we go. I run re1 stripped. I have no symbols like this. And I see this output, enter password and no. I'm going to go into Ghidra. And I'm now going to import re1 stripped like this. Okay. So I imported re1 stripped. And I clicked on the folder, hit the I key for, okay, now open up re1 stripped, analyze, everything's pretty much the same, except now I don't have the advantage of symbols anymore. So I hit G, I try to jump to main, and there's no main. So what can you do? Well, there's a couple different approaches. And as was just mentioned there, using strings is a really great approach. So I have some information from this binary here, which is the string enter password. So in Ghidra, what I'm going to do is there's a tab right here. It says defined strings. So you can click on that. And here's a list of all of the strings in the binary. Okay. Now, after I find all these strings, I filter the strings for pass and I find password. And it's okay if you didn't follow the whole strip thing. Like, we'll practice the skill. So, but I'll answer this question quickly and then we'll go on to RE2. We'll keep it going. So enter password like this. It shows me the place in the program that password is stored over here. And now I'm going to tell Ghidra, show me all the places where this string is used. So I list all the strings. I find out where it's stored. Then I check all the places it's used or references. Go all the way down here, right click, go to references, references to, like this. And that brings up this window here. Finally click here, which brings me to the main function. So same thing, except now there's no main symbol or label anymore. Okay. So, all right. So with that, let's move on to RE2 together. And I'm going to close out the code browser right here. It's going to ask me if I want to save. I'm going to say yeah, because I just renamed everything. So did a good job. Why not? Okay. All right. So let's move on to RE2. Thank you for your support. I was wondering if I was going to get that one or not. I just followed your instructions there. So RE2, this one's rude. It's unnecessary. You are all kinds of wrong. Who wrote this one? Sawmill probably wrote this one. I wouldn't write. I wouldn't do that. Okay, let's check out RE2. Opening up RE2, analyze like that. And now I'm going to try the same thing again. After opening up RE2, go to G, main. Hey, they got a main. All right. Oh, this one's kind of easy too, isn't it? Yeah, it's a little easy. Okay. So now we did the same thing with RE2. We got to main here. And what do we see? We see almost the same thing. Printf, wscanf, wcs, compare. Can I share the source? Yeah, they're right here. You have the source. This is it. Fix it up, rename it. So you can probably see this one too. So who's going to tell me what does W stand for here? What's up with these W's? Wide, right? Yeah. Okay. So wide strings. So here, let's do a quick fix up. Do the same thing. wscanf. And okay, look at this over here. So this one, what is this? Oh, this is a little tricky here. So now we have %ls. We got this big long thing right here. So let's try to fix this one up. Now, what type of data is this? Well, suggested is that they're wide strings, and we see a format string, %L and S, and it looks like each one is taking up 4 bytes, like each letter, as opposed to ASCII 1 byte, it's taking up 4 bytes. So here's what I'll try. Let's go right click here, go to data, and now let's experiment a little bit. Let's try a few things. So we could try string again. It didn't work, right? So that's not very good. Let's try terminated C string. No, that's no good. Let's try data terminated Unicode because, it's wide, right? Let's try this. Oh, that one didn't work for me either. That's no good. So why not? Okay, well, let's try to choose our own data type here. Here's what I'm going to try to do. Rage quit. Right click, go down here and rage quit. Okay. If anybody's rage quitting, here's what you can do. Go ahead and hit the C up here. Just click the C as hard. Just click it as many times as you can. Go ahead and click that. If you want to rage quit. Okay. If you click this C up here over and over again, the Ghidra developers put a little something special in there for us. So what else can we try here? Well, we try data, and I think the data type here might be Unicode This is the first time you've opened up a data type choosing window instead of selecting a basic one. Let's try Unicode. And then it says right here, Unicode 32. Try that one. Unicode 32. Thumbs up. That work for you? Oh, WCHRT. Good one. Yeah. All right. So we got %ls here. And then continuing on, we're going to rename this. And here we go. Rename variable. I like snake case myself. User input. There we go. And so print wscan, wstring compare, and like this. Yeah. Okay. Let's see if that works. Oh, did not work. Here we go. Oh, that didn't work either. Let's see. Gotta copy this here. All right. So does this work? It does. Congratulations. Terrific. Okay. Did anyone get this with strings? Did anyone actually could use the strings command to get this out? Because strings actually won't find it. If you run strings on it, you got to do some extra strings foo. There it is. Yeah, extra strings foo. So the default strings won't work for you. You gotta go into the strings options. So strings actually allows you to check out different encodings like that there. All right. So that one's pretty easy, right? Now, let's keep it going. That was RE2. And let's see what else we got here. Let's check out RE3. Okay. Analyze. All right. So we're at RE3. And let's give it a shot. So I'm going to try G main again. All right. Hasn't let me down yet. Oh, this one's getting ugly. Oh, boy. Oh, this is ugly. What is all this? So how could we know on Unicode 32 was the correct data type? Well, so my process that I showed you there was sort of like a realistic representation of what my process would actually be. I would try string first. String didn't work. I noticed that they were wide characters, that they were 4 bytes in size. So I know Unicode has the ability to have larger character sizes. So then I tried Unicode. Unicode didn't work. Then I typed in Unicode in the data chooser. So like you can choose data types, right? So here's like, so I tried strings first. That didn't work. Yeah. Tried string first. It didn't work. Where is it? I tried string, didn't work. I tried terminated C string. It didn't work. I tried terminated Unicode. It didn't work until finally I went to choose data type like this. And then under choose data type, I typed Unicode like that. And it made suggestions to me because the data type manager of Ghidra is terrific. It's great. You can do a lot of great stuff with it. You can define, of course, you can define your own structures and things. But so with here, I looked at the auto suggestions. It suggests Unicode 32. I tried that and it worked. Now I could tell you that, I recognized it as Unicode 32 because I knew Ghidra's data type manager, but more realistically, I try a few things and see what works. And then you kind of store that away as a good technique. Okay. So let's see with the request there of, can we get this into, let's see if we can get this into a situation where we can actually recompile this one. This one looks pretty nasty, but I think we might be able to do it. Let me give it a try. Okay, so this is RE3. I'm in the main function. Well, let me run RE3 too. Check this out. What does RE3 do? Enter password. No, let's try again. Yeah, see, this one's encouraging. I probably wrote this one. It's very encouraging. Okay. All right, so here we go. We got the same sort of thing happening again, except this time a little more difficult. But what I'd like to do is let me give you a couple minutes to just take a look at RE3. So I'll put like, I don't know, 7 minutes on the timer. And what I want you to do is I want you to go through RE3, the main function, and I want you to annotate in name and in type. Those are pretty much the only two things we've learned so far, which is rename things and retype things. I want you to rename and retype things until you get to a state of code which you think can be recompiled. And then we'll kind of pick it up from there. Okay. So want to see my sophisticated timer? Here we go. I'm going to give you 7 minutes. There you go. You got 7 minutes. Go for it. All right. We had about 7 minutes there. It's not very much time. Just enough time to give it a shot. And not easy. So let me see if I can do this. Give it a try here. Okay. So I see print, scanf, string compare. And so let's start fixing up the basics here. So print, scan, string compare. Okay, let's double click this. There we go. %s. So we're going to make that. We're going to do the same thing we did last time. So right click data, make that a string. Okay, %s. That looks good. Enter password. I'm also going to rename this like that. User input. There it is. And now, now it's getting tough. So if you couldn't do it, no big deal, right? So let's see what we can do. Well, as a programmer, you know that when you see, this is a cast, that's what that means. It means that this variable here may be declared as one type, but it's being used as another type here. And right here, it's being used as a char star character pointer. So string compare is, getting used as this here. So what this would suggest to me is that this is not the right type at this point. So how would we fix that? Well, one technique I used here is you could just look around, see where it is. So I see local 45. There it is up there. Local 45 is up here. Okay, so we need to change this type. That's what it is. So one of the techniques I like to use, middle click. That's like your scroll wheel. So go ahead and middle click like that. And what that'll do is that will highlight all the other instances where it's being used. So let's rename this to something a little bit more that makes sense. I'm going to rename this stored pass like that. So I got user input and stored pass like that. And now we see all the places it's used. And here I see it's defined as an undefined 8, which is, that's not a type. It's not a type I can compile or even think about. What is that? But what I do see here is stored pass is declared here. It's defined here. It's in this big mess, which I don't know what's happening here. What is all this? And then it's used again down here. Now, the fact that it's finally used in a string compare suggests to me that this is probably a type that's related to like a character pointer, right? And the fact that I see this here. Now, when I see this here, it stands out to me as these individual bytes are within the ASCII range. 42, 75, 75, 46. Each one of these is in the ASCII range. So what can we do here? Well, we could try a few things. Up here, stored pass, we could try making this, let's try a different type. So right click here, just like there's rename, you can retype. So I'm going to try a few things. I'm just going to try string. I'm doing this live. We'll see what happens. Ooh, fixed length data type required. Okay, good. So we have to be more specific than just string. Basically, this doesn't have like a lot of fancy features like, say, C++ or Java or whatever. You have to say exactly how long this is. And we can kind of see that right here. See stored pass? It shows you a length here. So let's make this maybe a character array we could try. We could also try char star instead of string. Let me try this. Retype. Let me try char star. So char star kind of works. Although what you notice here is that it's being, I changed the type and now it's added a cast. So that's usually a bad sign in Ghidra. Like if it's not, if you're adding more casts, it means the puzzle pieces aren't fitting together well. So let's try another one. And right here, this looks like, what is this? 1, 2, 3, 4, look at 8 bytes right there. So here's what I'm going to try. I'm going to make this, I'm going to retype this. I'm going to make this char and then in brackets 8. Try that. That made a huge improvement in my code. So I went up here and I found stored pass and I retyped it as a char size 8. It's kind of nice. So what you'll see here is everything kind of snapped together. You see string compare down here, no more cast. You see stored pass right here, no more cast. How about right here? No more cast. And right here, it's still assigned in a number. It would be nice if I could right click this and show the string, but I can't do it through the decompiler right here. Okay. Now, so this is a stored pass. Now, we haven't really had to leave the decompiler just yet. Actually, I'll tell you what, we're not going to leave it just yet. Let's fix up a few more variables. So the result of string length, let me rename this one. This will be str length and local 4c. Let's see, initialized to 0, used in brackets here, and then incremented. So what'd you call this? DI, I, CNT, index, I, counter. Yeah, okay. I guess, yeah, I'm going to go with index. There we go. Index equals 0. Okay, that looks good. Let's see. If string length is less than equal to u long index. Interesting. So that's a cast. Why is it being cast like that? I don't know. Well, it's set to an int up here. So we could try changing this to a long. Although string length is set to size t. Might be able to just change that. So here it's being cast because in the comparison here. So it's kind of up to us what we want to do. But as far as code is concerned, this actually looks like code that could be compiled. Well, I mean, it's getting closer. Anyway, it's not there yet. Up here in the main function, I would definitely fix this up, which I haven't shown you how to do that yet. But I'd definitely fix this up. But let's see if we can just get the password, and then we'll drive it all the way home as, you know, basically the as a compiled program. So yeah, another good suggestion there, retype it as size t. So if string length is size t here, then if we want to get rid of this casting, maybe we could resize that. Although I don't have casting here, I don't have casting in here. So it's kind of a trade-off, like what you want to do, but I think it's a good suggestion. So, but here's what I'm going to do. Let's see if we can figure out what this password is. And I see it's initialized. And then what happens to stored pass? Well, it's a while loop. It gets string length. And then it goes around and it says stored pass at index equals stored pass at index -1. Does anyone know what this is called? this particular algorithm. Decrement, rot one. Yeah, it's a rot one, I guess. Yeah. So you're shifting. So it's a shift cipher. It's a Caesar cipher. It's a very bad cipher. But what's happening is it's taking the original value of stored pass here. It's now shifting all of its contents by 1, and then it's comparing it to user input. So maybe we can just take all of these here and then actually shift these by 1, and then we'll get the password. Now, before you do that, before you bust out that pencil and paper and move as fast as possible, I want to just show you a couple things here. So one is I want to find out where this is over here. The decompiler is derived from a lot of the information that is shown over here. I would say that this window, the listing window, is the more definitive window. The decompiler is separate. Sometimes the decompiler will speculate about insights, and it'll even speculate about them and know it's speculating and saying like, okay, well, I'm not actually going to drive home those insights. So what I mean is, if you right click here, you'll see there can be local names that show up in the decompiler that don't show up in the assembly. And you actually explicitly have to tell the decompiler like, no, I think those are good. Let's commit those. So here's what we're going to do though, is we're going to reference this in the disassembly. So I click on it over here and it highlights, see how it's synchronized, right? So I click over here and I see RAX is going into stored pass. Okay, that's no big deal. I see move this like this here. Sometimes on the right side, you'll see some good comments or things like that. I don't see any comments over here. It's good. But I do see something that stood out. There's something that happened in the background here. When we made stored pass size 8, those other 2 variables underneath it disappeared. Did anyone notice that? There's actually more. I said 8 because it was stored pass, right? I'll show you. I'm gonna Control Z. So Ghidra has undo. So let me hit Control Z like this. There we go. So this is I hit Control Z a couple times, and I wanted to show you way back here where stored pass before, while it's still undefined 8, we see here that I just made it 8 bytes, right? So, but what about these? Local 3D, it's declared, it's assigned a value, and then it's never used again. So here's how I'd understand what is the relationship between this variable here and this variable here. I would look at the stack layout. So this is what you're going to do with me. You don't have to do those undos if you don't want to. You can leave your char 8 there if you want. That's fine. So here's what I want to show you. Over here in the listing display, because these are local variables, we know they're stored on the stack. So we're going to look at the stack in Ghidra. Over here in listing, up here on the top, this is like the top of the function, this block, not down here in anywhere of the code, but up here on the top. Right click, then go to function, then go to edit stack frame. Okay. So now that we're editing the stack frame, this is showing what Ghidra thinks the stack will look like at runtime. The stack isn't allocated until runtime. So this is sort of a notional view of what Ghidra thinks the stack will look like. So what we have here, stored pass, and then just beneath it, we have local 3D, local 3.9. So they're stored just underneath stored pass. So what I think is more likely, since they're all ASCII characters like that. Stored pass is stored right above local 3D, and these are not referenced anywhere else. I think Ghidra made a boo-boo. Ghidra screwed this up, which is okay because you're going to fix it. So instead of this being basically a char 8 right here, I think we should make this a char 13. That's the idea. So this gave me the insight over here, the stack layout. And then over here, I'm going to type it. So retype variable. And I'm going to make this char 13. Looks a little better, right? Now I haven't cut off, everything basically, but it still does. It still could be used. It could be improved still, But I want to show you my process, highlight some of the features. Let's see. Question there. Why is 12 not part of strings? This right here. Why is this not part of it? That's actually a really good question. So the question here is really why, when I made this char 13, why does it look all really funky like this? Why is this a block of 8? This is a block of 4, and then it's referencing the 13th element of stored pass array and setting it to null. Why isn't it just like the way I would write it? Why isn't it like looking good, right? Well, the answer here is that the process from compiler to assembly is a lossy transition. You lose information. What Ghidra is showing you here is not good programming practice, but it is the most accurate representation of what is actually in the disassembly here. See, these numbers they're not in a data segment somewhere. It's not like the string is stored in the data section and then it's loaded. It's actually hard coded into the program. There is a number. The compiler made a choice where it said, hey, that nice pretty string that you wrote. Well, I'm just going to hard code it directly into the code like this. And that's what happened. So Ghidra is showing you the most accurate representation, even though it is ugly as hell, right? It's like, what is that? So that comes on us. So the human plays the part of like, we got to fix that up. So, okay. So we fixed the typing there. And you see in the stack editor, it was actually reflected. Now we have something that looks a little nicer. Stored pass, user input. And now we don't have like those weird extra variables that weren't referenced. In IDA, you can get an ASCII representation. Yeah, definitely can. Yeah, it looks nicer in IDA. Can you go over one more time? Absolutely. Control Z. So here we are. We're in this situation here where everything is being casted all over the place, and I have undefined 8 stored pass. So what I'm going to do here is just right click, retype variable, and I'm going to make this a char 13 like that. So that's kind of what you wanted to do. Make that char 13. Okay. Yeah, the funny thing is IDA would actually give it to you in the correct order, not in little endian format, which is how it's showing us here. And it would actually combine these two. It wouldn't be separate. So we have to undo this manually. And it's funny because it shows it to you this way. Why can't it show it to me like this? This is the best I can get. So it needs some work. It needs some work. So yeah, well, the hover is, it's technically the most accurate way the hover is. So like this over here, what's actually in it, that's, yeah. So, okay. So let's try to actually get this password now, and let me fix this couple things here. This is the stat canary. If you don't know what a stat canary is, then take the exploitation class. We'll go all into it. And let me rename this to be index like that. And let me rename that one to string length like that. Okay, we're getting closer. Now, we pretty much have solved this puzzle. We have the original password, we have the cipher, and then we have the comparison. So what we need to do here is we need to take this and we need to take this and we need to basically transform it back, basically. So now, one thing that might actually help us here is if we could just run strings. There it is in strings, which is kind of nice. It's done the translation there for you. You can read it. 4.2 is capital B, U, like that. 4.5 is capital E. So there is like the string. But if you don't trust that, you can do the numbers too. So we can grab the numbers and let's go here. Go to Python, or I use Python. You use whatever you want. Okay. Let's go like this here. And let's go. Okay. Now, the absolute manual way here. Okay. So the absolute manual way to do this is you take it like this, and then like that. Everybody's got their favorite way to do it. This is like the long, tedious way that shows you what we're actually doing. So we're taking these numbers here like this. So these numbers are actually letters. There they are. See? Like that. And now what we're going to do is we can swap them around because they're actually in little endian format. Yeah. Ooh, Simon coming out with that crazy one-liner. So my preference for scripting Ghidra is actually using Ghidra Bridge. So if you like Jupyter Notebooks, there's this great project called Ghidra Bridge, like this here. And what you can do is you can copy over objects from Ghidra, because Ghidra runs Jython, which is stuck in Python 2.0. You can copy over objects into your Python 3 environment, manipulate them, and then send them back to the environment. So that's what we have set up here on our training version. So here's my customized Ghidra exploding bomb up here. But anyways, let me say I'm focused here. Let's get this password. Okay. Let's get this thing right. Okay. So here we go. Here's let's take all this and let's shift it by 1. Ooh, that doesn't look right, does it? That looks pretty messed up. Okay, let me undo that. Okay, so let's take this and we're going to shift it by 1. So stored pass equals this, and we're going to do 4ch in stored pass, and we'll convert this to numbers, because what we need to do is we need to undo the cipher. So we grab each character, or we can print out each character like that. And let's grab each character, and then we'll convert it to a number. So I use ORD in Python. And because the cipher does -1, I'm just going to do the same thing the cipher is doing, like that. And then what I'm going to do is I'm going to convert it back like this. And so here you can start to see something come together, right? Yeah. Hey, Viper, paste it in. So here it is. We take the original password, we go through each one, we convert it to a number, then we convert it to a character like this. But what you can see here is this looks, I mean, first of all, I can't tell what that is. Is that a password or not? I can't tell. But what you can, what something we will go into, and we would go more deeply into reverse engineering, is that this architecture that I'm using for my RE3 is called least significant bit. So it means basically that the bytes are stored in memory, backwards as considered from our. So I use this to flip the string around like that. And then let's do this here. Oops, like that. Yeah. There we go. There we go. So because it's least significant bit, you just have to flip it around in memory. And if that's new and weird thing to you, then I don't blame you, right? It's definitely weird. But we put that all together and we basically take these bytes in memory. We apply the shift, the same shift that it does. And then we just have to flip this around. So basically, put it all together and you get, undo the cipher. Now, there's a couple other things here that I'd change if I wanted to actually make this compilable. So here's one thing. Up here, this is a main function, and we can't have undefined 8 and void. I don't think that's not a good main. So here's what I'm going to do. Right click this and then go to edit function signature. And we're just going to retype the function. We'll just give it a standard signature. Like that, which is kind of nice because this is a function name. It has a return type. It has a name. This has a name. This is a type like this. So if you want to do it all together, one fell swoop, just right click and go to edit function signature. And then you can just type in it all in like that. Okay. Okay. Now, one of the last things that we'll do here is we're actually going to export the code. So that's one thing that we haven't done yet. So we want to get the source code out. Of course, you can just grab the code like this, but I wanted to highlight another feature of Ghidra, which is you can actually export the source code. So you go up here, go to File, and then Export Program. Let's go ahead and follow along with me in this one. File, Export Program, like that. And then you got a lot of options. So you're going to choose C, C++, like that. And it looks like it's going to output it to my home user directory, like that. Okay, has exported. And then going to my home user directory, I have a C file. Now, most of this stuff is not really relevant. Most of the stuff I don't really care about. But this I do. Okay. So there is something that's close to compilable, but not quite there. So here's what I'm going to do. I'm going to grab this and then write main.c over here and then do my last little touch-ups. And my last touch-ups are going to be fixing. I'm going to get rid of the stack canaries because those aren't put into source code. If you don't know stack canary, it's fine. You can just delete these lines like this. This is compiler generated. And then up here, let's see, and put some spaces in. Stored stack canary, that doesn't go in there. Doesn't go in there. And then let's see. I would probably fix this up too, because that is that's crazy. I would never write it like that. I would write it closer to the original thing like this. So I would grab this here. Whoops. And then we go back to my terminal. And let's do stored pass. How do I do this? Stored pass. Yeah. Okay. So I would go like this. We get rid of this. Don't need that. And don't need the cast either. It's also bad. That's weird programming like that. I wouldn't write it like that either, but you know, yeah, I would probably change this around a little bit more. Instead of having while true there, I would probably put this like that. So let's see, let's get rid of while true. It's up to you how much you want to deviate from like, how much you want to deviate from the original, versus like how much do you want to clean it up versus how much do you want to, be accurate, you know? So that's kind of up to you. So let's get that like there. And, oh, var one, that's not very good, right? Oh, how about this? Let's fix this up too. I put this, instead of having a whole separate variable, which I don't think is necessary. Like that. Does that look good? I'll tell you what, I'll give you a copy of what I got right now. You might find it useful. And don't need to escape this. All right, I'm gonna give it a shot. Oh, wow. So many warnings and one error. There we go. Did we get a compiled program? We did. There we go. So let's see. Have you reversed the logic? Don't you need equal equals 0 in the if? Well, I think I got rid of the if, didn't I? And this isn't a... oh, sorry. Yeah, I did. Thank you. Okay. Now, so you've learned a few different things here, that you can export code, that I'm a bad C programmer, and a bad Python programmer. So, but you can see what you can do with Ghidra. Now, is this your goal with using Ghidra? I mean, it really depends. So I want to step back here and I want to just tell you the other big features of Ghidra. What you just experienced was kind of like what it's going to be like to be in the training, which is, you know, we have some breaks, you know, like I can write it in the most, you know, I can write a solution in Python, but I'm trying to use the most explicit ones, like here, use the most explicit things so we understand it. We go through the details. We do exercises. It's hands-on. It's driven, things like that. That's what the training is going to be like. Now, as far as like other big things in Ghidra that you might be interested in, One of them is going to be all of the automation. So let me show you this over here. As far as those of you who might be interested in extending Ghidra, so you already got the manual process down. Well, we go over all the different interfaces. So there are many, many interfaces. There's prompts, there's scripts, remote Jython console, there's modules, there's tools, extensions. We go through all of this stuff and show you how to not only do things in Ghidra, which is mostly what we spent on, So keep in mind, for today, let's see here. Where did I go? Here. Okay. So for those of you who are pretty experienced already, we do ramp up quickly. Now, for today's workshop, no reversing experience was expected. So do we cover writing Slay? Well, let me go here. Here we go. Eclipse. We got P code, Slay, and then some Slay. Yeah. So we go through all of the, let's see here. Let me change this up because now we've upgraded like this. Yeah. So here's all the sync files. So we go through that. Although I would say that we have a separate Slay specific, people who have to do Slay, it's like a whole thing in itself. And we've done trainings, not really public ones, but ones for organizations in writing our Ghidra processors. So what you can expect about this Ghidra course is like reverse engineering, automation, extending Ghidra, and then some exploitation too. So we kind of put that all together and we show you if you're transitioning from IDA. Did anyone see how IDA's price change this week? Now it's a subscription basis. People want to take out some loans, I guess. So Ghidra IDA changed its pricing model. So now it's like it's now at a subscription basis. So a lot more people are coming over to Ghidra. They were like talking to me this week. So IDA's doing well business wise. I don't know, but as far as for Ghidra training, we're like, overwhelmed now with the amount of people that want us change over to Ghidra. So do we cover any P code emulation? Yes. So we do go over the P code emulator. For those of you who aren't familiar, P code is the underlying intermediate language. So like here, there's a whole bunch of code that Ghidra uses, single static assignment language like this here, and you can actually emulate this. So that is how Ghidra does some data flow analysis that's built in. So the Ghidra emulator, the Ghidra P code emulator right now is only accessible via the API. And so we go over like how to instantiate it and then basically how to emulate it to, deobfuscate a few things. So yeah, so basically that's a yeah. Okay, so we do some P code, although if you're interested, if you're like, you want to do a lot of automation, like you want to spend 5 days on automation, we do entire courses on just automation. If you want to do just Slay, we do, at 5 days and longer on just Slay. So the course coming up for Ring Zero is going to be introductory, like kind of like what we did today, except, it ramps up, it gets faster and faster as we go. And then the challenges get harder and harder. But then we also dive into other things too, like transitioning from IDA, automation, P code, Slay, extensions, things like that. So after 5 days, you have enough information to really be comfortable in Ghidra and then to start learning more Ghidra on your own, basically. So that's kind of that's kind of what you could expect from it. And what else I wanted to say here about Ghidra? So that's the Ghidra course. The exploitation course, which follows the Ghidra course, that's going to be using all tools, IDA, Ghidra, GDB, Jeff for GDB, if you guys know Jeff. Let's see. Question from Solomon. Exceptional workshop. Do you have the solutions write-ups to having the binaries you provided? I do have them, but I will not share them. So, and this is why. The idea is that the exercises are self-validating. When you finish the exercise, you know it. There is no question about it. It says congratulations. So I put those out there because you'll find that in the community of doing reverse engineering, finding exercises without solutions is actually very rare. Finding exercises with solutions, I mean, you find tons and tons of solutions all over the internet for every exercise. You can think of this as the few that you have that you don't have the solutions to. So that's kind of as a trainer, that's how I like to think of it as. But I am accessible in this Discord. You're on our Discord server. This isn't Ring Zeros. This is BCIs. That's who we work for. So that's who I'm an instructor for. So if you're interested, just hang out in this Discord server and you can ask questions, and then we'll keep going forward with exercises. Keep going forward. Okay. Let's take a look at it. So we got 5 minutes left. So I wanted to just open it up to any questions people might have, and we'll see if I can answer them for you. Okay. Let's see. Do you have any experience with Binja? So Binja is Binary Ninja. I do have some experience with Binary Ninja. I don't teach our Binary Ninja courses, but we do offer them, although I don't know if they're publicly listed. So our course is here at bostoncyber.org. You can find, these are where all of our courses, let's see, course catalog. So we cover a wide range, everything from, reverse engineering exploitation all the way up to, what do we got out here? Okay. Yeah. VxWorks. Some people are very interested in VxWorks. Might be interested in that. Let's see. We got ICS SCADA. I got this, one of our instructors, he's been building ICS systems and installing and maintaining for 15 years because of excellent class. And we integrate it with all the reversing exploitation stuff. So you can go ahead and take a look through all this. What else we got? How would you approach a large stripped binary? Well, to answer that question, think about a large binary, one that's like particularly difficult. Think about it like a jigsaw puzzle. You turn the box over, whether you have 100 pieces or you have 10,000 pieces, the methodology is the same. You find the corners, you find the edges, then you start grouping by color or pattern, and then you start moving, you take breaks, and slowly but surely you converge towards an answer. The methodology remains the same despite how large the binary is. So it's really just a matter of time, but the techniques will be consistent. Okay, question there. Pros and cons, IDA versus Ghidra. So IDA, I am a big fan of IDA's debugging capability. So I use IDA as a debugger with QEMU to do embedded systems and also GDB. Ghidra is starting to catch up with IDA. I mean, it's attempting, because Ghidra does come with a debugger. You may have seen that here. It's been around since like 10.4 beta development or something like that. But there is a debugger in Ghidra that's a front end for GDB. I don't think it's quite ready for prime time. It doesn't have the same reliability and flexibility as GDB does on its own. So when people ask me about debugging, I still recommend GDB and IDA. And Ghidra is, they'll get there. They'll get there. It's taking them some time. Let's see here. Any other questions you got about reversing exploitation training? Anything you got? Instead of rage quit, may I recommend rage break? Maybe some rage exercise. Rage coffee, rage walk around the park, and then a rage resume. Do you cover any debugger stuff with Ghidra in the course? Yes, I do. So the debugger is officially part of Ghidra now. It's no longer part of the development branch. It's the release. And so we do go over it, and I'll show you what it can do, what its limitations are, and how I complement it using GDB. And the platform, this is more representative of the platform that you'll get as a student. You get this virtual machine, and then the virtual machine has access to the debugger, QEMU. So we interface it with QEMU, but the short answer is yes, we do cover the debugger. Even though I think there are better ones, we do cover it though. Okay, how much memory do you recommend for running Ghidra? Well, for Ghidra alone, I don't know. I mean, let's just take a look. What is it? It's GNOME system monitor. Check it out. How much does Ghidra take up? Java's taking up 800. Yeah, right there. So it's taking up 800 megs, which is that's not nothing, right? That's something. So my process right here, running Ghidra, is taking up almost a gigabyte. So yeah. Let's see. Yes, but how do I get the snowman icon? Well, the snowman icon is a standard. If you really want to know about the setup here, this is OMyZSH, like this. And the theme specifically is the Agnoster theme. And you can have, you want to do the Ghidra prompt instead? You could do that one. So we'll do Ghidra instead. There we go. So you come to the course, you get the virtual machine, and you get to use it for, you get to take it with you. It's all the QEMU installations, all the cross compiling, stuff like that. All the cross compiling I did for this course, I did on this machine, and this is the student VM that you have. Do you get a dragon head? You get a dragon head emoji. The Apple dragon head emoji. I don't know if anybody noticed that. These are the dragon heads. Or these are the Apple emojis. Okay. Sorry, I'm 1 minute over time,